This article is related to statistical characterization of Terahertz 6G channel incorporating the molecular absorption and beamforming effects using the MATLAB. And the terahertz means this is basically a frequency range. Tera means 10 power 12, and communication means, yeah, like it means 10 power 12 hertz, enabling the 6G generation wireless networks due to its ability to support the ultra high data rates and massive bandwidths. And Monte-Carlo based channel simulator for the modeling of terahertz propagation at the 0.3 terahertz, incorporating the free space path loss, molecular absorption, and log normal shadowing, and Raytheon multipath fading as well. So the large scale and small scale channel statistics are obtained through the extensive Monte-Carlo realizations over the realistic approach. Okay, transmission basically distances. So the simulator can readily extend it to support the advanced scenarios such as mobility, adaptive beamforming, and multi-user links. It suitable for beyond the 5G research and standardized studies. So I have written the complete abstract with the keywords and introduction. In the introduction, I have written like how the terahertz frequency band has emerged as a promising candidate due to its availability of extremely wide bandwidths and operating in the range of zero point 0.1 to 10 terahertz. Communications enable data rates while well beyond those achievable with the millimeter wave technologies. However, the signal propagation at terahertz frequencies is fundamentally different from the conventional microwave and millimeter microwave bands. So here is the Monte Carlo loss distribution over the Monte Carlo received power distribution with the Monte Carlo SNR signal to noise ratio distribution with the frequency selective channel power dBm. dBm basically is the frequency range in terms of different bandwidth. Okay, so this is the 6G channel simulation, and the next one is that I have explained everything in this paragraph, and this is the motivation of terahertz communication. This is a new technology because people are growing to they want ultra high data rates, extremely low latency, and reliable connectivity for the emerging applications such as the holographic communications and immersive virtual reality as well. Okay. So the 6 gigahertz and millimeter wave bands are increasingly congested and bandwidth limited as well. Okay, so the propagation challenges is one of the most important topic in this because free space path loss increases rapidly with frequency, making terahertz links high sensitive to distance variations. Additionally, molecular absorption caused by atmospheric constituents such as the water vapor introduces frequency and distance dependent attenuation, and this effect becomes a particularly significant under varying humidity conditions as well. So directionality and wideband effects in terahertz is basically provide us the 6G system that are expected to utilize wide transmission and wide bandwidth, leading to frequency selective channel behavior. Need for Monte Carlo, yes, basically because we are going to work on a large scale of bandwidth, so that's why we need Monte Carlo simulation. In particular, enables the generation of large number of independent channel realization by the randomized distances. So the problem statement with the mathematical approach is that we have used the Ratian K factor, and we use the model wideband behavior across the frequency selectively introduced by applying the independent small-scale variations across the multiple subcarriers. These are the mathematical equations which I have used in the MATLAB design simulations, and in terms of signal to noise ratio, in terms of power, and total path loss as well. This is a methodology which uses the simulation parameters accordingly. And the next one is design of MATLAB simulation and analysis. In the MATLAB design simulation analysis, we have just used the 6 hertz Terahertz subsystem analysis, and Monte Carlo received power distribution as well. And this is a Monte Carlo SNR distribution. This is frequency selective channel power dBm. This and the output results as well. In the output results, I have just added like how OFDM base 6D system and the illusion of molecular absorption highlights the importance of atmospheric conditions as well. Monte Carlo results as well, and the conclusions with the references. Let me just provide you the MATLAB based demonstration of extended terahertz channel Monte Carlo distribution as well. These are the output results in terms of Monte Carlo. Okay, this is a Monte Carlo path loss distribution. This is a Monte Carlo received power distribution, Monte Carlo SNR distribution, frequency selective channel power distribution. Okay, so if you need to ask anything, you just ask me. I will answer your questions. Thank you.